This video is going to focus on the basic operations that you can do with your imaginary and complex numbers. So we're focusing on addition, subtraction, and multiplication when you're working with numbers that are just I or a complex number with A plus BI. First, it is important to understand what the number I is. It is the square root of a negative 1. Up until now, we've said that you cannot do the square root of a negative number. And that's because all the numbers that we had worked with up until now existed in the real numbers. So that's everything that you're used to, your natural numbers, whole numbers, integers, rational numbers, or irrational numbers. Those have all been real numbers. And we've ignored the fact that kind of complex numbers or imaginary numbers exist. And that is when you can do the square root of a negative 1. And that means that I squared is equal to 1. This opens up a world to a whole new level of mathematics and different problems that you can solve. A complex number is when you have two components. You have a real component, which doesn't have any I part in it, and you have an imaginary component or non-real component. This 1 plus 2i up in the top right is an example of a complex number because it has a real and a complex part, and that we use for our operations. So to start, we just have a few examples of basic operations. So a couple of multiplication problems here. So if you have 2i and you're multiplying by 3i, it's almost as if I is like the letter or variable x when our previous examples that we've done, where you just do 2 times 3, which is 6, and then you also have I times I, which is going to be I squared. So this is all going to turn into 6i squared. And then after that, we think about what I squared is, and from our previous slide, we knew that I squared was equal to negative 1. So we have to remember that is an important part in all of our work, especially our operations, that I squared is equal to negative 1. So really 6i squared is 6 times negative 1. And then finally, your answer is a negative 6. If you had 2i squared times a negative 5i, you would square this quantity, and so that would be 4i squared being multiplied by a negative 5i. So 4 times a negative 5 is a negative 20, and then I squared times the I is an I cubed. And we can break that I cubed down into two different parts where it's I squared times another I. That's important because we have to remember I squared is a negative 1, and you still have that negative 20 out front, so you have the negative 20 I squared times I, and then I squared again is a negative 1, and so this turns into negative 20 times a negative 1 times I, which turns back into a positive 20i. Finally, if you just had the square root of a negative 4, so there's no i's in here to begin with, but we do have the square root of a negative 4, which we've always said you can't do before. But the way we break this down and to see what the answer is going to be is that you could factor out this negative 1 that's there, the negative times 4, and so it's really 4 times a negative 1, and we've practiced simplifying radicals similarly to this before. So then you can do the square root of each part individually. So you have the square root of 4 times the square root of negative 1. The square root of a negative 1 is equivalent to I. The square root of 4 is 2, so this turns into 2i. Now you can also add or subtract your complex numbers. So this first example, you just have I plus 5 plus 3i. These are both examples of complex numbers. This just doesn't have a real number part, or the real number part is 0. You could think of it that way. So when you add these, all you really need to do is just think combined like terms. So add your I parts, so you have 3i plus i, which is 4i, and then it's just 5. So 5 plus 4i is your answer. Now if you have 5 plus 3i plus 5 minus 3i, this is an important example we'll be coming back to a little bit later. But for now, if we just add it, the 5's add together to make 25. Then you have a 3i and a negative 3i. Well, those things cancel out when you combine like terms, so your answer is just 25. And finally, if we had a negative, you would just have to distribute that negative. So the negative gets distributed to both parts, so that you have 14 and a minus 5, and then an I minus 3i when that negative gets distributed. So 14 minus 5 is 9, and I minus 3i is a negative 2i.